Okay, moving on to section 3.4, part 1. This is what we call partial fractions. So what we're going to be looking at when we're doing partial fractions, we are going to be integrating a rational function. So this right here is a rational function. So this is the type of problem that we're going to be looking at. So we want to be able to integrate a rational function. And to be able to do that, we need to use a method that we call partial fractions. And within these partial fractions, we need to be able to recognize three types of rational functions, okay? So this is a rational function, just means that it's a fraction with multiple functions within it, two or more. So we need to be able to recognize simple linear factors, repeated linear factors, and quadratic factors. Now there's a different method that we're going to use of partial fractions for each one of those different types. So you need to be able to recognize the different types, the three different types. And then I'll just tell you for this first example that I'm going to do that this is simple linear factors. When we talk about these factors, we are discussing what's happening in the denominator for all of those. So we're not looking at the numerator. The numerator can be the numerator can be anything. All of the homework problems that I've come across so far, the degree of the numerator is less than the degree of the denominator, and that is important. So your degree should be less up here. If it is not less, then what you would do is long division first, and then you would start doing your partial fractions. So the degree of the numerator needs to be less than the degree of the denominator. Okay, so we're going to take this example that we have right here, and we're going to work through this with partial fractions so that we can get it down to a function that we can integrate. Alright, so we are going to work through this example that we have right here and show you what we mean by the partial fraction decomposition. So we're starting off with the fraction 3x plus 2 over x minus 2, and x plus 1. Now our denominator, we have all linear factors, which is a good thing. So what that means, and I'll go into more of how I know all of this information here in just a minute, but for right now, I'm just going to show you. So what that means is I can break up this fraction to a over x. So see, I'm going to take each one of these factors. There's the x factor, x minus 2 and x plus 1. I'm going to split them each into different fractions, fraction of their own. So b over x minus 2 plus c over x plus 1. So each one of these values, a, b, and c up here, are going to represent constants. So no functions up here for any of these. We'll get into more detail about that later. But for if we have linear denominator factors, then we're only going to have constants in our numerator. So if you remember back when we worked with partial fractions, no, not partial fractions, sorry, these fractions with functions in the numerator and denominator, rational functions, that's what I'm trying to think of. So when we worked with these functions right here that we call rational functions, because there are functions within a fraction, what we did is we multiplied both sides of the equation by the least common denominator. And then what would happen was we would be able to clear all of our fractions out. So in this case, on the left-hand side, our denominator is x, x minus 2, and x plus 1. On the right-hand side, we have an x, x minus 2, and an x plus 1. So this whole denominator right here is going to be our least common denominator. So we're going to multiply both sides of our equation by that least common denominator. So I'm going to multiply by x, x minus 2, and x plus 1. Now I kind of didn't leave myself enough room over on that left-hand side, so I'm just saying I'm multiplying this whole equation by this least common denominator. Okay, and let's put a 1 underneath it so you don't get confused with our fractions and we're multiplying too. So the first thing that we're going to do is we're going to multiply all of this. We have to distribute it all the way through. So we're going to multiply it all the way over here to what's on the left-hand side of the equation. Well, what's going to happen, everything here is going to cancel out with all of that. Okay? And we're going to be left with 3x plus 2. So no fraction left at all. Only one in the denominators, which is right, is 3x plus 2. Now we've got to multiply to this term. Okay, when I multiply to this term, we're going to have the a. But what happens with my x's? My x here and my x here are going to cancel. So I'm going to have a times what's left over. So a times x minus 2 and x plus 1. Okay. All right, so we're done with that one. Now we're going to multiply to this whole thing by the next term. So when I multiply to b, now my x minus 2's are going to cancel. So I'm going to have b and plus, so this is a new term. So plus b times x plus 1. Okay. And now for our very last one, we are going to multiply all of this to our last term, which is c. And then we're going to have plus c. For c, our x plus 1 terms will cancel. So we'll have c times x minus 2. Okay. A lot of multiplying here. So we have 3x plus 2. Let's multiply all of these parentheses out. So this is going to be x squared minus 2x plus 1x is going to give us a minus 1x minus 2 plus b times x squared plus x, and then plus c times x squared minus 2x. Okay, very good. So now let's move on. Let's get rid of the rest of our parentheses. So now we have ax squared minus ax minus 2a plus bx squared plus bx plus cx squared minus 2cx. All right, now let's keep bringing down this left-hand side with us. So now the whole purpose in this now is to combine my like terms. So I've got an x squared term here, here, and here. I've got x terms here. Ooh, I forgot an x there, didn't I? Let's go back. This should have been bx squared plus bx. Aha. Good thing we caught that. Okay, so minus ax, there's an x term, plus bx, there's another x term, and minus 2cx is another x term. So we're going to combine all of those, and then we have just one constant term, the minus 2a. So I want to rewrite so that all of my like terms are together. So now I have 3x plus 2 equals ax squared plus bx squared plus cx squared. So that's all of our x squared terms. We got all of those taken care of. So now let's go to our blue, and I'm going to make that a plus a negative ax, and then plus bx, and then minus 2cx. Okay, and then last of all, we have our minus 2a that is our constant. So now I'm going to go ahead and factor out the x squared term. So once I factor out x squared, I'm going to leave it on the right hand side. So factor out the x squared, I'm going to have a plus b plus c as my coefficient to x squared. And then for my coefficient to x, I'm going to have negative a plus b minus 2c. And then for my constant, I'm going to have minus 2a. All right, over here on the left-hand side, we have this 3x plus 2. But since I am looking at my coefficients, I need to have an x squared coefficient because I don't have one over here right now. I do have a coefficient for x, so I know I want this coefficient for x to equal 3, and I have a constant, negative 2a, which I know needs to be equal to plus 2. So let's fix our left-hand side. Let's rewrite that left-hand side so that it has an x squared coefficient. There's not one, so we put in a placeholder of 0x squared plus 3x plus 2. Now we can go through here and write some equations. We know that a plus b plus c must equal 0. We know that negative a plus b minus 2c must equal the coefficient to x, so it must equal 3. We also know that minus 2a is our constant, so it must equal 2. So let's write a system of equations that shows all of this in one place. So we know that a plus b plus c must equal 0. We know that negative a plus b minus 2c equals 3. And then we know that negative 2a equals 2. So this is a system of equations that we want to solve. So very first thing, we can solve for that a pretty easily. We know right off the bat that a equals negative 1. So now let's rewrite our other two equations. So if a is negative 1, plug in a negative 1 for this a, add it to both sides, we would get b plus c equals positive 1. So b plus c equals 1, and then in this next one, plug in our negative 1 to a. We would have the negative. If a negative 1 becomes positive 1, subtract it from both sides, we'll get 2 on the right-hand side. So b minus 2c equals 2. Okay. I just double checking on my work. Okay, we're good. So now we need to set up a system of equations that we can subtract and cancel out one of these variables. So let's go ahead and multiply this top equation here by 2. Now we have 2b plus 2c equals 2. Now our second equation, we've got b minus 2c equals 2. So now if I add those two equations down, my c's are going to cancel. So I end up with 3b equals 4, and therefore we know that b equals 4/3. We also already found that a equals negative 1. So let's take one of these previous equations and solve for c. I'm going to take that first one, a plus b plus c equals 0. And so I have a, but since I'm working in thirds, I know I'm going to have to add these two fractions. Let's go ahead and write that a down as negative 3/3. So a plus b plus c must equal 0. Negative 1/3 plus 4/3 is going to be 1/3 plus c equals 0. Subtract 1/3 from both sides, and we'll get c equals negative 1/3. And so that becomes our answer. In most of the problems, I think you have one homework problem that you'll actually have to write out what the whole decomposition is, the partial fractions. But most of them are just asking, what is a, what is b, and what is c? The answer that we would actually end up with when we want to integrate would be equal to a over x. So we found a to be equal to negative 1. So we'd have negative 1 over x. Plus b, what did we find b to be? b was 4/3. So I would write that as 4 over 3 times x minus 2. And then c is equal to negative 1/3, so I would have negative 1 over 3 times x